For our next problem, we're giving a list of relations, and we're asked to list any relation that is not a function. So let's start with A. In A, we have a set of 3 ordered pairs. Now, how do we determine whether or not these ordered pairs represent a function? Well, here's the key. We look at the first elements, 7, 8, and 9. If no first element is repeated, then it automatically is a function because we cannot have any first element paired with a second element and then have that same first element paired with a different second element. So A represents a function, so we're not going to list that. Let's look at B. B has a first element of 5 paired with a second element of 7. And then notice we have a first element of 5 again, but it's paired with a different second element of 8. So because this 5 is paired with 7, and then 5 is again paired with something different, 8, it makes it not a function. So B is not a function. Now let's look at C. In this case, we're not given a list of ordered pairs, so we have to figure out a different way to determine whether or not it's a function. And what we'll do is a vertical line test. Here's what the vertical line test says. It says if you can take a vertical line at any point on the graph and it touches the graph in more than one place, then this does not represent a function. In other words, y is not a function of x. Well, let's try it and see. I can draw a vertical line right here, and notice it touches the graph certainly in more than one place. So it fails the vertical line test. Therefore, we can also say C is also not a function. So on this page, B and C were both not functions. Let's look at a couple more. In D, we actually have an equation. So the easiest way to determine whether or not this represents a function is to solve it for y. So we could say y squared equals 100 minus x squared. And then we could certainly take the square root of both sides. So we'll get y is equal to plus or minus the square root of 100 minus x squared. Now notice what happens. If 2 or more values of y can be obtained for a given value of x, then the equation is not a function. So suppose we put in a value for x like 0. That's an easy value to put in. We would have plus or minus the square root of 100. That means y would give us 2 different values for one value of x, and therefore it would not be a function. So we'll also list D among those that are not functions. Finally, in our last one, E, we have a graph again. Remember the vertical line test. If we can draw a vertical line anywhere along the graph and have that vertical line touch the graph in more than one place, then it's not a function. In this case, it doesn't seem possible. I try passing my vertical line across the graph, and in no place does it touch the graph more than once. So E is a function, and I won't list it as not being a function.